Good morning. Today we are going to start the next lesson, Kinematics of Particle. Okay, it is a part of dynamics. I told you that dynamic is that branch of mechanics in which we are going to study the motion as well as forces responsible for that motion. Here, in dynamics, we are going to study the motion and forces. This dynamic is further divided into two parts. Here, the first one is kinematic, and second one is kinetic. Here, so kinematic is that branch of dynamics in which dynamics further divided into two parts, kinematics and kinetic. Here, I already explained you that in this introduction. Here, once again, I will give in 2 minutes. Kinematic is that branch of dynamics in which we are going to study only motion. Here, without considering the forces responsible for that motion. Means whenever the forces are not involved in the sum, there are forces. Without forces, the motion is not possible. Here, but in this kinematic, we are going to just study the motion and relation among the different parameters of the motion like velocity, displacement, acceleration. Okay, so that comes under kinematic. Yeah, there are the kinetic is that branch of dynamics in which we are going to study the motion as well as forces. So when the forces are involved, the sum is on kinetic. Here, Newton's second law and all these things. Here, F equal to ma. Here, in this kinetic, we are going to study the relation between the different parameter and the corresponding forces. Here, in kinetics, we are going to study only motion. Study of motion means what? The study of motion means the study of velocity, displacement, acceleration, and the relation among them. Here, that study we are going to do in kinematics. Yeah. Now, this kinematic as well as kinetic is further divided into kinematic of particle and kinematic of rigid body. Similarly, the kinetic is also divided into two parts. Here, kinetic of particle and kinetic of rigid body. Okay. Now, what is the difference between these two? Yeah, the first one, what is the difference between the particle and the rigid body? Here, so, related to our subject, here, the particle is considered as a dimensionless object. Here, dimensionless object is considered as a particle. Here, whereas the rigid body is having some particular dimension. Here, it occupies certain space. It has some specific shape and size. Here, so this is a particle. This is the rigid body. Here, but now related to our subject, here even aeroplane, bus, train can also be considered as a particle. Here, in this consideration, here we are not going to consider the internal motion of that. Here we are going to consider as a motion of the whole train as a particle. Okay, that's why the train can be considered as a particle for that particular physical phenomenon. Here, for example, suppose one bus is there. The bus moves from suppose Vasai to Churchgate. Yes, now in this motion, here when that bus, or let's consider the local train. Local train starts from Borivali here to Vasai. Okay, now from Borivali to Vasai, here with at what acceleration it started, here up to what time or up to what distance it moves with that acceleration. Here then with some distance it moves with a uniform velocity, that is the acceleration is 0, and after that to stop at Vasai it has to decelerate and finally it stops here. So to study this motion, how much time is required, how much distance is covered, what is the acceleration, what is the intermediate velocity. Here for all these things you don't have to, you don't require to consider the length of the train. Here, so that length of the train is an irrelevant dimension for that physical phenomenon. And in such cases, we can consider that train as a particle. Okay. Here, so particle is what? It is a dimensionless object, whereas the rigid body is having certain dimensions. Here, next important thing related to our subject here, the difference between the particle and the rigid body. Very important difference. Here, when we consider any object as a particle, here there are the forces acting on that particle or that object. When we consider it as a particle, always form a concurrent force system. Okay, when any object is given and the different forces are acting on that object, and if you are considering that object as a particle, then that forces form a concurrent force system, because a particle is a dimensionless object. If it is a dimensionless, we can assume that, or we can consider that the forces are passing through the same point on its mass center here, and the force system become a concurrent force system. Whereas if the object is considered as a rigid body which is having some dimension, then the force system become a general force system. Okay, here in case of a particle, the corresponding force system become a concurrent force system. In case of a rigid body, it become a general force system. The next important thing here related to this concurrent and general force system, here since the forces acting on a particle always form the concurrent force system, so under the action of the concurrent force system, the rotational motion is never possible. Here, for the rotational motion, here we require the unbalanced moment. Here, and the concurrent force system will never produce the unbalanced moment. Here, the unbalanced moment present in this system is always zero. Here, that's why the concurrent force system will never produce the rotational motion. Here, so under the action of the concurrent force system, only translational motion is possible. Okay, and that's why here whenever there is the object is considered as a particle, where this particle undergoes only translational motion, particle doesn't have the rotational motion. Okay, what is the reason? The reason is this. Here particle is a dimensionless object, and the forces acting on that dimensionless object here are considered as a concurrent force system, and under the concurrent force system, the rotational motion is never possible because the unbalanced moment is zero in that case. Okay, whereas when the rigid body is there, here the force system acting on the rigid body can be considered as a parallel force system or the general force system. Here, and under the action of parallel or general force system, the unbalanced moment is possible, and that's why may be possible or may not be possible, depends. So under the action of general force system, the rotational motion may be possible, and because of that, here when this rigid body is there, here and the forces acting on the general force system, here then under the action of this general force system, this rigid body undergoes the translational motion. Translational motion produced only if the summation of the moment of all the forces becomes zero, if there is no any unbalanced moment. Here, but if there is an unbalanced force as well as unbalanced moment, here then along with the translational motion, there may be a rotational motion also. Here, so rigid body undergoes the translational as well as rotational motion, whereas the particle undergoes only translational motion. Here, what is the reason? Reason is the force system. Here, have you understood the difference between the rigid body and the particle? Any difficulty? Here, so in this lesson, first you have to study only kinematic of particles. Here, now after this I will not give this introduction to you. Here, after this we have to study the kinematic of rigid body. Here, so when we study the kinematic of rigid body, we have to study the translational as well as rotational motion of the rigid body. Here, we have to study one more type of motion in kinematic of rigid body, that here which is a combination of translational and rotational motion. For example, the motion of a wheel of an automobile. Here it has a translational as well as rotational motion simultaneously. That motion is known as a general plane motion. Here, so that general plane motion we have to study in kinematic of rigid body, and kinetic of rigid body is also having the same motion here, but there are some forces and the moment and torque will also be there. But this part is not in your syllabus of fourth semester. Here, kinetic of rigid body you are going to study in fourth semester in kinematic of machine. There is one less subject, kinematic of machine. In that kinematics of machine or kinematics of machine or a dynamics of machine. Here, dynamics of machine, in that one you are going to learn this kinetic of rigid body. Understood? Here, not in first year. This in dynamics altogether you have to study these three lessons: kinematic of particle, kinematic of rigid body, and kinetic of particle. Some part of this kinematic of particle, here you have already studied at your junior college of +2 level. Here, kinematic equations, motion under gravity and all these things here. Similarly, the some part of this kinetic of particle also you have studied, like a Newton's second law, work power energy and all that things. Okay, here. So we have to cover up it very fast. Yeah. Okay. Then this lesson, the kinematics of particle, I already told you that the kinematics is the study of motion here, and in that one we are going to study the motion of particles. Since we are going to study the motion of particle, the particle undergoes only translational motion. Particle doesn't have the rotational motion. Then this translational motion of a particle is further divided into two parts. One is rectilinear translational motion, and other one is a curvilinear translational motion, or it is a circular motion. Circular motion is one type of curvilinear motion only. Here, now what is the rectilinear translational motion? Rectilinear translational motion, when the particle moves along the straight line, maybe horizontally, maybe vertically, and that motion is known as a rectilinear translational motion. For example, the motion of a free falling object. Here, motion of the free falling object. Here, in that case, the object or particle moves along the straight line. So that is known as a rectilinear translational motion. Whereas when I throw the particle with some inclination, here that is a projectile motion. Here, so that projectile motion is a curvilinear motion. Okay, here, can anybody unmute and tell me what is the path traced by the projectile if it is a projectile? Which type of curve it plots? Projectile?
Parabolic. Parabolic.
It is a parabola. Okay, here, so it may be any curve, not in projectile, but for any other particle, it may be the any curve. But when the particle moves along the curved path, the motion is known as a curvilinear motion. Here, so in this kinematic of particle, here which undergoes the translational motion, we have to study these two: rectilinear translational motion and curvilinear translational motion. Now, whether it is a rectilinear translational motion or the curvilinear translational motion, here we have to study the motion, and study of motion means what? It is a study of motion is nothing but a study of velocity, displacement and acceleration and the relation among them. Okay, here, so you should be very much comfortable with this, all the terms here. What is displacement? Here, what is the velocity? What is acceleration? Here, out of that, the displacement is very important and confusing. The first one is displacement. Displacement is a vector quantity. For complete specification, we require its magnitude as well as direction. Here, now this displacement is denoted by S, normal here general letter which used as a S. Here, if the displacement is along x-axis, here we can denote it as a x. If the displacement is along y-axis, we can denote it as a y. Here, but S is a common letter which is used to denote the displacement. Here, now the important thing is that how you are going to define the displacement. Tell me.
Shortest distance between the start point and end point.
Okay. Shortest distance between the start point and end point. If this is the starting point, if this is the end point. Here that this distance is 5 meters. Yes. So can you say that here 5 meters is the displacement? Yes or no?
Yes.
Okay. Now, just now I told you that the displacement is a vector quantity. Okay, displacement. Your answer is not wrong. Okay, your answer is correct here. But just now I told you that the displacement is a vector quantity. And for complete specification of a vector quantity, we require its magnitude as well as direction. Now you said that it is the shortest distance between the starting point and the end point. Here, so this you use the word distance. Here, whereas the distance is a scalar quantity. Okay, so this becomes the distance, 5 meters. Okay, then what is displacement? Or if you say that this is the displacement, then what is its direction? What is the direction of the displacement vector?
Shortest path between 2 points.
Then tell me what is the direction of that? It is a vector. So you tell me which vector? Displacement vector is which vector?
5 meters from O to A.
5 meters from O to A. Means you mean to say that if I ask you at point A, what is the direction of displacement vector? So कौन सा डायरेक्शन रहेगा उसका, और ओके लेट इट बी here now it to be more precise here. Now when the particle is at point A, here can you tell me what is the displacement vector? Tell me how much is the displacement vector?
Sir, we will have to add a arrow here to show the displacement, like to show the
Add a
direction.
arrow.
Then
Okay, that only I am asking. Here so कौन सा arrow आएगा इधर to express the direction of the displacement?
sir, if you are traveling from O to A, then there will be an arrow at A.
Okay, arrow at A. We are considering that only. Here somebody said that is start point A, O and end point A. Here so you mean to say that it is OA. This is the direction of the displacement vector, isn't it?
Yes, sir.
Okay, and if you want to express it in the vector form, here then the magnitude is 5 here and
I
this the I cap, right? It is 5 I cap here. So this 5 I cap is the displacement vector. This is the displacement vector. So this becomes the magnitude, this indicates the magnitude, and this I cap, this indicate the direction. Here from this I cap we can conclude that this displacement vector is along positive x-axis. Here, understood? Okay. So what is displacement? Listen. Suppose one particle is moving in the xy plane. Here, and let this is the position of a particle at any instant of time t. Here, कहाँ से start हुआ, कहाँ पे end हुआ, that doesn't matter. Okay. Here, let A is the position of the particle at any instant of time t. Here, then with respect to this origin, this vector OA bar, here represented displacement vector. Here it represents displacement vector. Here it represents the position of particle A with respect to origin at time t. Here, so if anybody asks to define displacement, so displacement is nothing but the instantaneous position of the particle. It is the instantaneous position of the particle at any instant of time t with respect to the origin. It is the instantaneous position. Here, displacement is nothing but a position vector with respect to some origin. Here, whenever you want to express the displacement, here always you have to consider it with respect to origin. Here, without origin, the displacement has no meaning. Okay, here so displacement is nothing but a position vector here, and if it is asked to define the displacement, here so displacement is nothing but the position of a particle at this particular instant of time t with respect to origin. Okay, here now origin is a reference point. Here without this reference point we cannot express the displacement vector. Okay, now where to take the origin? Here you can take the origin anywhere here, but in most of the time, here we are considering the origin as a starting point of the particle. Here the point from where the particle begins its motion, that point can be considered as the origin, but not hard and fast. Okay, apart from that also you can consider any origin and you can write down the displacement vector. Here, but we are going to consider as a starting point as a origin. Here for displacement is nothing but the position vector of the particle with respect to origin. Here, and it expresses the position of that particle at this instant with respect to that origin. Here, let's consider suppose one particle start from O here, and A is the position. अगर ये particle यहाँ पे है, then at t equal to 5 meter, at t equal to 5 seconds. Here, this was the position at t equal to 0. यहाँ से particle start हुआ, and this is the position at t equal to 5 seconds. Here, and let this distance is suppose 10 meter. Here, so at t equal to 5 seconds, this OA bar, it is the position vector. Here, it is the position of a particle with respect to origin. Here, so it is a position vector whose magnitude is 10 meter. Okay, so this is the magnitude, this is the direction, and this is the time. So displacement is what? It is nothing but a position vector. Here, which expresses the position of a particle with respect to origin at any instant of time t. Here, so here I can say that at time t equal to 5 seconds, here the displacement of the particle is 10 meter towards right. Here, now while solving the sum, you can express it in the vector form also, but most of the time here we are not going to use the vector approach. Here we are going to consider the magnitude. Here, but displacement is a vector quantity. We are going to consider this direction. We are going to use the sign convention. Here, and what sign convention we are going to use in rectilinear motion? Here, with respect to origin, if the particle is on right side, here irrespective of the direction of motion, here it is a instantaneous position. What time पे उसका position क्या है? That only, irrespective of the direction of motion. Therefore, irrespective of the direction of motion, if the particle is at this point A, here, and if this is the origin, here, then this will become the displacement vector, isn't it? This will become the position vector. And since this position vector is directed towards right, so this displacement can be considered as a positive. Means at any instant of time t, if the particle is on right side of the origin, the displacement can be considered as positive. If the particle is on left side of the origin, the displacement can be considered as a negative. Why? When the particle is on left side of the origin, what will happen? In that case, the displacement vector will be towards left. That's why it is negative. Yes. Similarly, if the particle is moving along the vertical line, for example, the motion under gravity, here, or the motion of the free falling object, here, with respect to this origin, let the particle thrown from this building. Here, so let's consider this itself as the origin. I already told you that we are going to consider the point from where the particle starts its motion, that point as the origin. So if I consider this as the origin, so with respect to that origin, when the particle is above origin, then this OA bar becomes the displacement vector. Here, and since it is directed upward, so we are going to consider as a positive. In short, when the particle is above origin, irrespective of the direction of motion, the displacement vector can be considered as positive. If it is below origin, here the displacement vector is downward, can be considered as negative. Means when this particle reach at the bottom of the building, with respect to this origin, at the bottom of the building or on the ground, its displacement will be negative. Are you getting it?
Yes,
Have you
sir.
understood this sign convention? Okay, so this is all about the direction. Now magnitude. What is the magnitude? Now if I consider this as the origin and this point as a A, this is the position of the particle at any instant of time t, and with respect to this origin, here in the coordinate of this point are 5 and 4. Let this origin is 0, 0. These are the coordinates. So what is the position vector of A? It is 5 I cap plus 4 j cap, isn't it? Here this becomes the position vector of A. Yeah, and this position vector itself represents the displacement. Means when this particle is at point A, here at any instant of time t, so displacement vector can be written as SA bar is equal to 5 I cap plus 4 j cap. This is the displacement vector. Here, this is a component of this displacement vector along x-axis. This is a component of the displacement vector along y-axis. Here, now what I was talking about the magnitude of this displacement vector. Here, then what will be the magnitude of this displacement vector? Here, now if this is x coordinate is 5, means this distance is 5 meter. Y coordinate is 4, means this distance is 4 meter. Here, and this is the displacement vector at this particular time. What will be its magnitude? It is under root of 5 square plus 4 square, isn't it? Here, and this under root of 5 square plus 4 square, 5 square plus 4 square is nothing but equal to the distance OA, which is equal to distance OA. Here, so the magnitude of the displacement vector here, or the magnitude of the displacement, is nothing but the shortest distance from origin. Here, so after this, whenever I'll ask you what is the displacement of a particle at any instant of time t, here you have to tell me the shortest distance from origin. Here, don't say that the shortest distance from starting point and end point. It is the shortest distance from origin. और origin कहाँ पे लेने का? So you can consider the origin at the starting point. Here, same thing है. आपने जो बोला वही मैं बोल रहा हूँ. Okay, but in a different way only. Okay, here so displacement is the shortest distance from origin, and here you have to consider the origin. Most of the time, the origin is we are considering at the beginning of the point from where the particle begins its motion. Here, have you understood this concept of displacement? Here, now I will ask you some questions. Unmute yourself here and answer my questions. Here, now we have to little bit increase the speed. Okay, here. So suppose one particle is moving along the straight line. This is the position of a particle at t equal to 0. Here, this is the position of particle at t equal to 5 seconds at A. Particle towards right जा रहा है. At B is the position of the particle at t equal to 8 seconds. Now at point B, the particle reverse the direction of motion and reach at origin at t equal to suppose 12 seconds. and C is the position of the particle at t equal to 15 seconds. Okay, and here on this line, motion line, here this OA distance is suppose 6 meter, AB distance is 3 meter, here and this OC distance is 4 meter. Okay, particles start from origin, move towards right, reverse the direction of motion and move towards left, here till 15 seconds. So let's consider this journey of the particle from t equal to 0 to t equal to 15. Yeah. Now before this, before asking some questions here, I would like to tell you about the distance traveled. Distance. Okay. Displacement is a vector quantity, whereas the distance is a scalar quantity. Here distance is always positive. And how can you define the distance? So distance is nothing but the length of the path traveled by the particle in that duration of time. Here displacement is not the length of the path. It is the shortest distance from the origin. Here, whereas the distance traveled is the total length of the path traveled by the particle in some interval of time. Here, listen carefully, displacement is the instantaneous position at that particular instant, whereas the distance traveled is the length of the path traveled in some duration of time. Here, to travel very small distance, even we require some duration of time. And that's why we always say that the displacement at t equal to 10 seconds. But we never say that the distance travels at 10 seconds. Here, actually, it is distance traveled in 10 seconds, not at 10 seconds. Okay, if I say that the distance traveled at 10 seconds, somebody may say that, sir, at 10 seconds, here it's okay, but from which time to which time? Here, whether you want a distance traveled by the particle from 9 seconds to 10 seconds, or from 8 seconds to 10 seconds, or from 0 seconds to 10 seconds. Okay, here, so distance travel is the length of the path traveled by the particle in some interval of time. If it is asked to calculate the distance traveled by the particle in 10 seconds, and which 10 seconds of its journey, if it is not mentioned, here whether you want to calculate the distance traveled by the particle in 10 seconds from 5 to 15, or from 11 to 20, here, or from 21 to 30, here, if it is not clearly mentioned, then by default you can consider that it is first 10 seconds of its journey from 0 to 10 seconds. If it is not given. Okay, here, then what is the distance travel? It is the total length of the path traveled by the particle in that duration of time. And if that duration is not given, by default you have to assume it as the first duration of the time. Here, if it is in 10 seconds, then first 10 seconds you have to consider. Okay. Now related to this motion, yes, you have to tell me here the displacement and the distance traveled. Displacement and the distance traveled by the particle. Yeah. Now tell me, at t equal to 0 seconds, at t equal to 0 seconds, the particle is at O, origin. Yeah. So when the particle is at t origin at t equal to 0, how much is the displacement of the particle?
0.
It is 0. It is 0 because displacement is the shortest distance from origin, minimum distance from origin. इसके बाद में कभी भी पूछता हूँ कि how much is the displacement, you have to tell me the shortest distance from the origin. Yeah. Then at t equal to 0, how much is the distance traveled?
0.
Again 0.
0.
Okay. Yeah. Then at t equal to 5, at t equal to 5 when the particle is at A, how much is the displacement?
6 meter.
It is plus 6. It is plus 6. Why plus 6? Because the particle is at right side of the origin. अगर मैंने displacement vector दिखाया तो displacement vector is directed towards right. That's why we are going to use it as a plus 6. Understood? Then how much is the distance travel in 5 seconds? Now I am talking in 5 seconds. Now when I say that in 5 seconds, then by default it is from 0 to 5. Yes. So 0 to 5. How much is the length of the path traveled by the particle?
6 meter.
6 meters.
6
Here, and it is always positive. It is the distance is a scalar quantity which is always positive. Okay. Then at t equal to 8 seconds, when the particle is at point B, how much is the displacement?
Plus 9.
9.
Plus 9 meter. Plus 9
9.
meter. And how much is the distance traveled in 8 seconds? In 8 means 0 to 8. Yes, so that is also 9 meter.
9.
If I ask you how much is the distance traveled by the particle from 5 to 8 seconds, How much is the distance traveled by the particle from 5 to 8 seconds?
3.
5 to 8 seconds, it is equal to 3 meter. How you have calculated this? Then this distance traveled by the particle from 5 to 8 seconds is equal to the displacement at 8 seconds minus displacement at 5 seconds. Isn't it? Here, displacement at 8 seconds, this becomes the displacement at 8 seconds. And this is the displacement at 5 seconds. Here, so displacement at 8 seconds minus displacement at 5 seconds, you will get the distance traveled by the particle from 5 to 8 seconds. Here, have you understood this? Okay.
Yes, sir.
Now, at point B, the particle reverse the direction of motion. At point B, the particle reverse the direction of motion. We are not talking anything about the velocity. Okay. It reverse the direction of motion and it come back to the origin at t equal to 12 seconds. और ये जो time है वो beginning से count कर रहे हैं हम लोग. Okay. So at t equal to 12 seconds, the particle come back at origin O. Here, so at this t equal to 12 seconds, can you tell me how much is the displacement?
0.
Minus 9.
0.
Which is minus something. It is 0. Here, at t equal to 12 seconds, the displacement is 0. Here, because displacement is the distance from origin. Particle origin पे है, तो displacement 0. Here, वो किधर से भी घूम फिर के आने दो उसको. अगर वो origin पे आता है, मतलब उसका displacement, position उसका 0 हो गया with respect to that origin. Okay. Here, but in 12 seconds, how much is the distance travel? Then it is the
18.
total length of the path.
18 meter.
18 meter. Okay. Then at t equal to 15, the particle moved in the forward direction. Here, and it is on the left side of the origin at t equal to 15. So how much is the displacement at t equal to 15?
Minus 4.
Minus 4.
Minus 4.
Here, so again, the particle at point C, the displacement vector will be towards left, and that's why the displacement is minus 4. But how much is the distance travel in 15 seconds?
22.
22 to
20 meter.
0 to 15 सेकंड चाहिए मुझे. 0 to 15. यार, तो 0 to 15 ये पार्टिकल डायरेक्ट यहाँ से यहाँ पे नहीं आया. 12 to 15 वो यहाँ से यहाँ तक आया. 0 to 15 के बीच में वो कहाँ पे गया? It moved rightward and then at the reverse direction of motion and come back at point C. So how much is the total length of the path traveled by the particle? It is 9 plus 9 plus 4. 9 plus 9 plus 4.
22 meter.
22 meter. Okay, I hope that your idea about the displacement and distance is covered. Now you will observe that in this table, here up to t equal to 8 seconds, up to B, here you will observe that the displacement is equal to the distance traveled. But after 8 seconds, the displacement is not equal to the distance traveled. Okay, here, so what you will conclude from this? Can you maybe conclude if why up to 8 seconds the displacement is equal to the distance traveled, but after 8 seconds the displacement is not equal to the distance traveled? Why?
So direction change.
Change in direction.
Change in direction. Yeah, change in direction. Yeah, so remember one thing. यार अगर कोई पार्टिकल ओरिजिन से स्टार्ट होता है, आई एम टॉकिंग अबाउट द रेक्टिलिनियर मोशन, अगर कोई पार्टिकल ओरिजिन से स्टार्ट होता है, ओके यार, एंड इफ इट मूव इन द सेम डायरेक्शन, यार जब तक ये डायरेक्शन चेंज नहीं करता है यार तब तक डिस्प्लेसमेंट इज इक्वल टू द डिस्टेंस ट्रैवल, तब तक displacement is equal to the distance traveled in that interval of time. But once the particle reverses direction of motion, here उसके बाद में displacement is not equal to the distance traveled. वो direction कौन सी भी direction में change होने दो, okay? यार जब तक वो एक ही direction में move होता है, जब तक direction of motion does not change, then the displacement is equal to the distance traveled. But once the particle reverses the direction of motion, the displacement is not equal to the distance traveled. Here, in that case, the displacement will be, distance travel will be greater than displacement. Okay, तो इसके बाद में याद रखो, अगर particle is moving in the same direction, और question में अगर दिया है कि it travel a distance of 10 meter in 5 seconds, yeah, so that 10 meter you can consider as a displacement at 5 seconds. Here, because this formula S equal to ut plus half at square, here this formula will not give you the distance travel. ये distance travel का formula नहीं है. This is the formula of displacement. Here, ये displacement का formula है with respect to origin. Okay, here, so Don't get confused between the displacement and the distance traveled. Therefore, if the particle move in the same direction, then the displacement is equal to the distance traveled. Any doubt in this one? Yes. And when in the question it is asked, we have to calculate the distance traveled. Suppose one particle starts from origin, and let A is the position of a particle at any time t1 and B is the position at any time t2. And if it is asked to calculate the distance traveled by the particle from t1 to t2, how you can calculate that distance traveled from t1 to t2? From t1 to t2. Okay, so this distance traveled by the particle from t1 to t2 is equal to here mod of, how I can get this? It is the displacement at t2 minus displacement at t1. Displacement at t2 minus displacement at t1. Here, ये क्या calculate करने का है? This is the origin. So this distance is the displacement at t equal to t2. So this becomes the st2 and this becomes st1. So how we can get this distance traveled by the particle from A to B? It is st2 minus st1. Have you understood this? Here again condition is that here you can directly take it mod of st2 minus st1 only if the particle move in the same direction in this interval of time. But if the particle reverse the direction of motion in that interval of time, here then you cannot take directly. Suppose in this question, let's consider this question. ये question में मुझे पूछा है, here find out the distance travel from 5 to 12 seconds. Question पूछा है, distance traveled by the particle from 5 to 12 seconds. This for the position at t equal to 12 seconds. Let this is t1 and this is t2. You have to calculate the distance traveled by the particle from 5 to 10 seconds. Can I use that? Can I use this? st2 minus st1. Here st2, which is equal to s12, 0 है, and st1, which is equal to s5. here कितना है? 6 meter है. Okay, so if I use this formula S12 minus ST2 minus ST1 mod of, here, so it becomes 0 minus 6 means answer is 6. Is it traveling 6 meter only from from 5 to 12 seconds? No. So this answer is wrong. So you have to use this formula only if the particle is moving in the same direction in this interval of time. अगर ये interval में particle is moving in the same direction तो ही ये formula use कर सकते हैं. यार यहाँ पे क्या हो रहा है? From 5 to 12, the particle reverse the direction of motion. Since the particle reverse the direction of motion in this interval of time, you cannot use that formula. Okay, तो फिर इसमें distance travel कैसे calculate कर सकते हैं? Yes, so to calculate the distance travel in this interval of time, if direction reverse अगर होता है, if the direction is reverse, yes, then what you have to do? You have to split this interval 5 to 12 सेकंड का जो इंटरवल है वो दो पार्ट में स्प्लिट करने का है. Here, ये T1 to T2 का इंटरवल है. Here, and let in this interval T1 to T2 at time t the particle reverse the direction of motion. Here, then you have to split this interval into two parts. T1 to T एक इंटरवल and T to T2 another interval. ये दो इंटरवल आपको स्प्लिट करने का है. Here means to calculate the distance traveled by the particle from T1 to T2. Here you have to calculate the distance traveled by the particle from T1 to T. T is the time where the particle reverses its direction of motion plus distance traveled by the particle from T to T2. Okay, and then this distance traveled by the particle from T1 to T, you can use this formula because from T1 to T the particle is moving in the same direction. At T it reverses its direction of motion. So from T1 to T, it is moving in the same direction, and from T to T2, it is moving in the same direction. So in this separate interval, you can use that same formula. So here it becomes mod of St minus St1 plus in another mod, it is St minus St2. And doesn't make any difference whether you are writing St minus St1 or St1 minus St because we are taking it in the mod. Okay, here. So you have to split that interval into two parts if the particle reverse the direction of motion. Here समझ में आया क्या? Any doubt? The next, velocity. Here velocity is that physical quantity with the help of which we'll come to know how fast the particle is moving. Here it gives you an idea how fast the particle is moving. It gives you an idea how fast the particle changing its पोजीशन। क्लियर, कितना फास्ट अपना पोजीशन चेंज कर रहा है, उससे आपको वेलोसिटी का पता चलता है। If any particle changing its position very fast, very frequently, it means that the velocity is more. Here, or the speed is more. Yes. So first I will talk about the velocity. So what is the velocity? Okay. Now let's consider one particle is moving along this straight line. Let this is the origin, and this is the position of the particle here at time t. Let A is the position at time t. Here the displacement is S. Let the displacement is SC or SA, and let B is the position of a particle here at time t plus delta t. B is the position of a particle at time t plus delta t. Here the displacement is SA, or where the displacement is SB. Okay, let here the displacement is SA. Now in this motion here, in this interval of time delta t, when the particle moves from A to B, the time interval is delta t. And in this delta t, let the change in displacement is delta s. Delta s is the change in displacement in a time interval of delta t. Okay. So in this question now, we can write from A to B, here this ratio of change in displacement per unit time. Here the change in displacement per unit time, here this ratio or this term change in displacement per unit time is known as the average velocity. It is known as average velocity. So average velocity of the particle is nothing but the change in displacement upon change in time. Here remember this formula. Average velocity is equal to the change in displacement upon change in time. We can write final displacement minus initial displacement due to the change in displacement upon final time minus initial time due to the change in time. So this becomes the average velocity. Now let's consider during this motion, this time interval A to B, this time interval is very, very small and approaches to 0. Now, if this time interval is very, very small and approaches to 0, this B point will coincide with A. Okay, here, and when B coincide with A, here this term becomes here the limit of delta S upon delta T, where delta T approaches to 0. Here, and this becomes ds by dt, which is known as the instantaneous velocity of the particle at this time. Here, क्योंकि ये इसके ऊपर overlap हो गया, delta t का interval very small हो गया, and instead of the average velocity, now this becomes the instantaneous velocity, which is commonly known as the velocity. So when I say that the velocity, it means that it is the velocity of the particle at that particular instant of time t. Okay, here, so average velocity is the change in displacement upon change in time, whereas the instantaneous velocity, the name instantaneous, it is at that particular instant only. Next instant पे कुछ अलग भी हो सकता है. Here, so instantaneous velocity is v equal to, it is limit of delta s upon delta t when delta t approaches to 0, which can be written as ds by dt. Here, which is the rate of change of displacement with respect to time. So velocity is the rate at which the displacement is changing with respect to time. Here, that term is known as a rate of change of displacement. Here, those who have studied the mathematics properly, जिनको limit क्या है, derivative क्या है, वो पता है. Here, for them, it is easy, not that difficult. Yeah, but whenever I'll ask you what is the average velocity, it is the change in displacement upon change in time, and what is the instantaneous velocity? It is the rate of change of displacement with respect to time. Yeah. Any difficulty about this velocity? Okay. Then next, what is the direction of the velocity? Velocity is the velocity vector. Then what is the direction of the velocity vector? Can anybody tell me what is the direction of the velocity vector? Here, ये instantaneous velocity vector का direction क्या रहेगा? What will be the direction of the instantaneous velocity vector? इसका मतलब आपने 11th 12th में स्टडी नहीं किया फिजिक्स, यू आर नॉट स्टडीड फिजिक्स प्रॉपर्ली.
So it will be in the direction of which the particle is traveling.
Okay. If the particle is traveling along the chord path, then
डिस्प्लेसमेंट के डायरेक्शन में होगा।
डायरेक्शन ऑफ द मोशन ऑफ द बॉडी।
अभी देखो यहाँ पे पार्टिकल, ये ऐसे पार्टिकल मूव हो रहा है, कर्विलिनियर मोशन है। अगर मैंने ये ओरिजिन कंसीडर करता हूँ एंड दिस इज द पोजीशन, देन दिस बिकम द डिस्प्लेसमेंट वेक्टर। तो वेलोसिटी का यहाँ पे जब पार्टिकल यहाँ पे रहेगा तो वेलोसिटी का वेक्टर, वेलोसिटी वेक्टर किधर रहेगा? व्हाट इज द डायरेक्शन ऑफ द वेलोसिटी वेक्टर इन दैट केस? यार तो रिमेंबर हियर, नाउ आई एम नॉट गोइंग इन डीप यार, नहीं तो इसमें ही टाइम चला जाएगा। जस्ट रिमेंबर whether it is a curvilinear motion or whether it is a rectilinear motion, here velocity vector here is tangential to the path. कैसा रहता है? It is tangential to the path. Now why the velocity vector is tangential to the path? Here इतना मैं deep में नहीं जाता हूँ। Here that is related to the direction of this change in displacement vector. Here it is related to the change in displacement vector. Okay, here. So you refer your physics book of 11th and 11th mostly. You will get the answer of that. So just remember, whenever I'll ask you what is the direction of the velocity vector, so direction of the velocity vector is tangential to the path traced by that particle at that particular instant. किधर रहता है velocity vector? Answer my question.
Tangential to the path.
बस
traveled by the particle.
अभी इसके बाद में कभी भी पूछता हूँ कि व्हाट इज द डायरेक्शन ऑफ द वेलोसिटी वेक्टर, हियर आंसर यही आना चाहिए कि टेंजेंशियल टू द पाथ ट्रैवल और ट्रेस बाय दैट पार्टिकल। ओके, नाउ लेट्स कंसीडर इट इज अ कर्विलिनियर मोशन। अब ये कर्विलिनियर मोशन है, लेट इट इज अ पैराबोला। व्हेन दिस पार्टिकल रीच हियर, या तो इसका वेलोसिटी का वेक्टर किधर रहेगा? सो एट दिस इंस्टेंट इट इज टेंजेंशियल टू दिस पाथ, वेलोसिटी ऐसा रहेगा। फिर अपवर्ड रहेगा या डाउनवर्ड रहेगा? Actually it is in the direction of the change in displacement vector, but आपको इतना ही याद रखने का है कि if it is the direction of the velocity vector which is tangential to the path but consistent with the direction of motion, if this particle is moving downward, then the velocity vector is downward. If the particle is moving upward, the velocity vector will be upward. So it is tangential to the path and consistent with the direction of motion. Yes. Now if it would have been a rectilinear motion, here suppose this is the position of a particle at any time instant of time t and particle is moving towards right. What is the direction of the velocity vector? तो इसका path कैसा है? Straight line है। तो straight line को tangent, straight line को tangent means it is along the straight line only, isn't it? Here, so when there is a rectilinear motion, the velocity vector will be in the direction of motion. Directly you can say that it is in the direction of motion. If the particle is falling, so at any instant of time t, the velocity vector is downward. Here it is in the direction of motion. Here automatically वो tangential to the path आ जाएगा. Okay, and consistent with the direction of motion. Here, so in rectilinear motion, when I ask you what is the direction of the velocity vector, it is always in the direction of motion. In curvilinear motion, it is tangential to the path and consistent with the direction of motion. Here, in it out. Is that clear? This is all about the velocity. Here, then next one is the speed. Speed is a scalar quantity and which gives you the idea about how fast the particle is moving. Here, so speed or the average speed can be written as total distance traveled upon total time. Okay, here speed or the average speed is the total distance traveled upon total time. Here gives you the speed. Okay, in it out. Any doubt? Yes. Which lecture do you have next?
BEE.
At what time? At what time?